Hello, how are you? Salam alaikum. Welcome back to another question of strength, right? Whereby I'm gonna be doing a couple of them, right? They throw in their shear stress diagram. I have a couple of questions here, a couple. So I'm just gonna be doing a few of them, right? So, but then I'm gonna separate the video so that it don't be like that much long, right? So I'm gonna start with this question right here. Okay. Uh, Let me put this here. Good morning. Well, okay. So here is going to be my first question. My first example, right? Which is example number 1, right? So we have a beam, right? And it's fixed here, right? And then there's a UDL, like a uniformly distributed, right? And it's going downwards, right? And that's it, nothing else. Yeah, downwards, 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 right? 1.5 kilonewton per meter. And then here is C, this is B, this is A, and then from here to here is 1.6 meter, and then this whole thing is 2 meters. Okay, and we're required to solve this and write the shear, like and draw the shear stress diagram. We know this, we're going to multiply, right? We're going to say 1.5. We want to make it like a very pointly force, right? So if you're going to make it a pointly force, it is going to be in the middle, right? So it's 1.5 multiplied by 1.6. So, and then here I said if it's fixed, we want to have a force, right, and a moment. So it's going to be RA, right, and MA, right? So here it's going to be 1.5 multiplied by 1.6, which is 1.5 multiplied by 1.6, right, gives us 2.4. That means the force here is 2.4 kilonewton, right? And is in the middle. So the half of 1.6 is what? Is 0.75. Yeah. 1.6 divided by 2. Or 0.8. Sure. Okay. So here is 0.8, right, from here to the end. That means from here to there is gonna be 2 minus 0.8, right? Which gives us 2 minus 0.8, which gives us 1.2. That means from here is 1.2 meter, right? That means we can easily find this. Upwards. RA is equals to 2.4. That one is simple, right? And then let's take moments. We want to take moments about A, right? Okay, moments. And I said clockwise is positive, right? And then anti-clock is negative, right? Okay, now I'll hold this. I'm taking moment about A. That means I'm holding this here, right? So that I can minus the RA. I'm holding this here, right? And then it's like this. So there's 2.4 kilonewton force here. and then it's pushing this like this. Then this thing is going where? It's going clockwise, right? So it's gonna be 2.4 multiplied by this distance from here to here, 1.2, right? And then for it to balance for this moment, because you see there's no other moment, so for this moment to balance each other, we know that the other one has to be negative, so it's going to be minus ma is equals to 0, right? Therefore ma is equals to 2.4 multiplied by 1.2, which is 2.88 kilo Newton meter, because it's a moment. Okay, we found everything. Now let's draw our shear stress diagram. Okay. Okay. Now our shear stress diagram is going to be simple actually. So is our beam, right? And then we have a right by okay 1.2. Nah, I should draw this one. I wanna draw it like the first one, not this one. Okay. Okay, let's just forget about this one. Let's just say let's draw it here. Right? Take me back home. This is actually simple, don't wanna lie. But it's not complicated. But so we have MA and we have RA and we have 1.5 kilonewton per meter, right? So here's 1.6, right? And then here is 0.4. From here to here is the distances, right? So our shear stress diagram is gonna be, because changes happen where the force starts, right? So this one, don't think about it. Okay, here's our beam, right? And then here is our shear force, and this is our bending moment, right? Our shear force, everything starts at 0, so RA, it goes upward 2.4, which is here, so it's gonna be 2.4 kilonewton, right? And then it goes straight, right? And then it goes down how much? 2.4 back to 0, so that means it's gonna be like this, back to 0. You see, simple. Simple, right? Now our moment, look at this. There's a moment here. There's a moment MA, right? So that means our moment one on this initially they won't start on 0, right? So that means our moment is 2.88 kilonewton, right? So we're gonna go down 2.88 kilonewton minus 2.88 kilonewton, right? I'm just say kilonewton meter, right? So that means I'm gonna write this here. So this simple bending moment at A which is here, edge B, which is here, and edge C, right? Okay. If I look at this here, my bending moment at A is going to be minus 2.88 kilo Newton meter, right? And that means my bending moment at B is going to be here, right? My bending moment at B is going to be minus, I included, minus 2.88, right? We hold it here like this, right? But then there's another force here. There's RA. This time RA, we're counting him, right? It's pushing him upwards. So it's going to be clockwise, right? Plus, it's going to be positive. Plus RA, which is what? 2.4. 2.4 multiplied by the distance from here to here, which is 0.4. 0.4 is equals to, right? And then the moment it's 0, we know that it's going to give us 0, but then 0. But then we're just going to make sure minus 2.88 plus 2.4 multiplied by 0. No, multiplied by 2, not 0.4, multiplied by 2, right? And then plus, is it plus? Because we're holding it here. No, it's minus. It's minus because this force is going to be, this force here is going to be pushing it anti-clockwise. Going to be pushing it anti-clockwise. So it's going to be minus 2.4, right? Multiplied by minus 2.4 multiplied by 0.8. 0.8. I hope you all said it. So this ends up giving me, let me calculate this one first. Minus 2.88 plus 2.4 multiplied by 0.4. It gives me minus 1.92, minus 1.92, right? And then this one multiplied by 2 minus 2.4 multiplied by 0.8, which is 0. Good. That means here I've done everything correct. 0 kilo Newton meter. That means my moment here is going to be minus 1.92 minus 1.92 minus 1.92, right? And here it's going to be 0, right? This one I know is going to go straight, right? But then this one I have to ask myself, how do I go from here to here, right? Okay, here's the trick, right? When you're moving, when you look at the distance, because here you're moving from big to small, right? From big to small. So that means from here I'm gonna have to move, like the distance, I have to move big to small. Look at this. I'm moving from, like, look at the distance from here to here. So you're gonna be moving like you're gonna be enclosing the distance big to small. I hope you understand me. The distance from here to here, right? You're moving, like you're closing it big to closing it small. Because here you're moving from big to small. If you were moving like from small to big, you will wanna enclose it a little bit, a little bit, a little bit, and then to big. I hope you understand me. But then you'll see it in the next question maybe. Then then you'll get to understand it very well, right? So here is 0. And yes, and that is how we draw the shear stress diagram for this, right? But then I'm gonna do more questions and then you get to understand very well. Because strength, in order for you to understand, you have to do like as many questions as you can, right? Okay. Oh, I'll see you guys in, because here there's no point of contraflexion. I'll see you guys in the next question. Right. I'm out.